So, when you're trying to make an AI smarter, you usually hit this fundamental fork in the road, right? Do you build it to be a better thinker, or do you just give it more information to pull from? Well, let's get into it, because some new research is pointing to a third path, and it's way more interesting.
And this is really the core question. It's kind of like asking, what's more important for a person? Being a genius at solving puzzles, or having a photographic memory? For a long, long time in AI, the answer has basically been, just make the memory bigger. But what if we could actually teach it to be a better problem solver instead?
So, just to make sure we're on the same page. Thinking harder, that's like cracking a tough puzzle. It takes logic, it takes steps, it takes actual reasoning. Knowing more, on the other hand, that's like remembering a fact from history class. You either know it or you don't. It's all about recall. And look, AI has gotten scarily good at recall. But the reasoning part, that's where things get really exciting.
So here's what we're going to cover. First, we'll unpack this AI thinking dilemma. Then we're going to look at two really clever solutions researchers came up with. First, making an AI loop to think harder, and second, giving it a memory. After that, we'll dive into the results, which are pretty surprising, and see what it really means for an AI to get smarter, not just bigger.
Okay, first up, the AI thinking dilemma. The whole issue is this. How do we get better reasoning out of these models without just making them bigger and bigger and bigger, which, costs a fortune in time and energy?
The old school way to do it is just to stack more and more unique processing layers on top of each other. The best way to picture it is like a library. The traditional approach is to just keep adding new floors, each one packed with totally new books. Sure, more floors means more knowledge, but man, is that an expensive and inefficient way to build.
And that brings us to the first big idea, looping to think. This is a totally different way of getting more brain power out of a model without actually making it bigger. So instead of adding another floor to our library, what if we just told the AI to, sit down and reread a really difficult chapter a few times until it finally clicks? That's exactly what a looped model does. It takes the same exact processing block and just runs the information through it again and again, getting a little smarter with each pass. So here's the key takeaway. A looped transformer gets all the benefits of being deeper, which really just means it's doing more steps of thinking, but without actually adding any more parts. It's a ridiculously efficient way to squeeze more reasoning out of the exact same hardware.
But there is a catch. Of course there is, and it's a big one. This quote from the paper just nails it. A model that's designed to reread the same books over and over might become a brilliant thinker, sure, but its library is still pretty small. It just has fewer places to store raw facts. So we've made it a better thinker, but we've also made it, a bit forgetful.
So how do you fix that? Well, that leads us to the second piece of the puzzle. You add a memory. If our deep thinking AI has a small library, why not just give it a perfectly organized set of flashcards, a cheat sheet basically, to get that knowledge back?
And that's what the researchers did. They bolted on this memory bank. It's not just random info either. It's a set of learned facts. Think of them like flashcards that the model can quickly check anytime it realizes it needs to know more instead of think harder.
They actually gave it two different kinds of memory. There's a local memory, which is like a private set of notes for each individual layer. And then there's a global memory, which is like a big reference book the whole model can share. But here's the really genius part, the gated access. The AI actually learns when to check its notes, so it isn't wasting time looking up stuff it already figured out.
Okay, so the theory is beautiful, right? A model that can think harder when it needs to and has a cheat sheet for when it gets stuck. But does it actually work in practice? Well, let's take a look at the results, because this is where it gets good.
First, let's look at math problems, a pure test of thinking harder. On the left, that's your standard model's error rate. On the right, that's the loop model. Just by letting it rethink the problem, the error rate dropped by 22%. That's not a small bump. That is a massive win for the looping approach. But what about that knowledge problem, the forgetfulness? This chart shows how well the models did on common sense questions. The first bar, that's our looping model on its own. It does okay. But look at the second bar. When you add that memory cheat sheet, its accuracy shoots up, getting incredibly close to the third bar, which, by the way, is a traditional model 3 times its size. The memory works. It really closes the gap.
So let's just put that all together. When you combine the looping and the memory, you get the best of both worlds. This new hybrid model was actually better at math than a model 3 times bigger, while using its memory to keep up on the knowledge-based stuff.
It's a huge deal for making AI more efficient.
And all of this leads to the last part of the story. And honestly, it's the most mind-bending part. It's not just that this new model is better, it's how it's better. The AI is literally teaching itself how to learn more effectively.
Check this out. This graph shows how many times each layer in the model decides it needs to loop. The early layers, those lighter colored lines on the left, they learn to stay low. They barely loop at all. But as you move to the deeper, more complex layers on the right, whoa, look at that. The model learns on its own to think harder for the tough parts of a problem. And this quote from the researchers just sums it all up perfectly. Nobody programmed this. Nobody told it, hey, use more loops for semantics. It developed its own strategy, all on its own. It learned when to think, when to remember, and which part of its brain to use for each job. So just to quickly recap how this works, the early layers in the model basically handle the easy stuff, like grammar. They don't need to think too hard, so they use very few loops. But as the problem gets passed deeper into the model, the later layers kick in to handle complex meaning and reasoning. And it's those layers that spontaneously learn to loop more, to really dig in and think harder right when it counts.
And that leaves us with this final, pretty wild thought. We've just seen that an AI can do more than just follow its programming. It can actually develop its own strategies for thinking. So if an AI can learn how to think, what kind of problems is it going to decide to solve next?